Hello, friendly greetings. Tisai here with a ramble. Before we go very far, I would like to begin by shouting out today's commenter, Material Girl. I don't know how to say the second part. It's giving BTS. It's giving BTS energy. It's giving K-pop. Eh? But yes, thank you so much for sharing the love. It really does uplift me so much, encourages me so much whenever I see comments like these, and I just get a sense that the stuff is helping someone somewhere in the world. That really makes me so happy. So thank you for stopping by. And with that being said, let us look at today's question. We are dealing with the Department of Education's paper 1 from May 2022. Question 3.1. Consider the following geometric sequence: 1024, 256, 64. So this is a decreasing geometric sequence, which tells me that the common ratio is a proper fraction, right? So we are dividing by something each time. Righty doos. So first task is for us to determine the 10th term of the sequence. Okay, so they've already told us it's geometric for free, so we can just go straight ahead and use the geometric sequence formula, right? So we know that Tn is given by a times r to the n minus 1. So what do we know? What do we need to know? We're trying to find out T10. That's what we don't know. What we do know is that our first term, A, is 1024. R is the ratio between term 2 and term 1, or term 3 and term 2, whatever. So we can just take term 2 and divide it by term 1, or you could take term 3 and divide it by term 2. Okay, and if you put that in your calculator, I think that will give you a quarter. Okay, right. Maybe let's double check that. Let's not be arrogant. Haha, let's be arrogant. Okay, so r is a quarter, i.e. if I times this with a quarter, I get this guy. If I times this with a quarter, I'll get this term, and so on and so on. Right, and then finally our n is 10. Okay, so now we can put that into our formula. We have a times r to the n minus 1. Okay, what does that give us? Whoa. Let's get our calculator out for that one. To the power of 10 minus 1, which is 9. That gives us 1 over 256 will be our 10th term. Right. Then the next part of the question, we're looking at the same geometric sequence, and then we're asked to calculate this sum. So it is the sum from p is equal to 0 until p is equal to 8. And this is the term that we are adding each time, 256 times 4 to the 1 minus p. Okay, so I mean, initially I'm not entirely sure like what is the relationship between this and this, as. So what I like to do is I would, expand, maybe get the first 3 terms. So it's going to be 256 times 4 to the 1 minus 0. That will be term number 1, and then 256 times 4 to the 1 minus 1, and then 256 times 4 to the 1 minus 2, and so it goes. Oh, it's a phone call. Okay, yeah, I will have to get back to my person shortly. Anyway, so now I need to wrap this up. So the last term will be 1 minus 8, right? Where p is equal to 8. So I'm going to simplify each term now. So it's going to be 256 times 4, and then here we're going to have 256 times 4 to the 0, which is 1, and then we're going to have 256 times 4 to the minus 1, which is a quarter. Okay, and so it goes until we have, oh oops, already have the ellipses. 256 times 4 to the minus 7, so 1 over 4 to the 7. I don't know what that is. Okay, but now we start to see how this is related to this, because 256 times 4 is 1024, and then the next term will be 256, and the next term will be a quarter of 256, which is 64, right, if you calculate that. And then this weird number now at the end, it's just calculated for completion's sake, even though we don't need to. You could just leave it like that. 1 over 64. Okay, okay, right. So we see that actually we are calculating a series based on this pattern, right? And to be more specific, so how many terms does this series have? It's tempting to say 8, but remember that we didn't start at p is equal to 1. We started at p is equal to 0. So if you just imagine that it was 0 to 1, how many terms would it have? It would have 2 terms, right? So likewise, from 0 until 8, it's going to be 8 plus 1 terms, because of that p is equal to 0 term. So this is a geometric series where a is equal to 1024, like we had before. R we've already calculated as a quarter. The number of terms in the series is 9, right? So we are working out, essentially we are working out S10 in disguise. That's what we are working out, right? So the formula for geometric series is a times 1 minus r to the n. Remember, we use the 1 minus r if the r is a fraction. It just works out nicer. But you can also use the 1 where it's r minus 1. Same potato. Anyway, so now we're going to replace our a with 1024. Our 1 minus a quarter to the 9 over 1 minus a quarter. Okay, let me shrink this a little bit, put it in a little sparkly cloud. Okay, that's not sparkly, but anyway, you know. So this is where that's coming from. Righties, so this is a good moment to whip out the oh my gosh, whip out the calculator. So we have 1024, 1 minus a quarter. Okay, right, and then down here we have 1 minus a quarter as well. Perfecto. So that ends up being, I mean, we could keep it as a fraction. Doesn't look very nice, but okay, we don't discriminate here. So that is the answer, I think. Let's see what the memo has to say for itself. Speak or forever hold your peace, memo. So the first answer we agree is 1 over 256. Perfect. Allegedly, not allegedly, I'm looking at the memo. I am literally looking at the memo, and it says if you had just written down the answer, you would have gotten full marks. Awesome. Do not try this on other questions. Show your workings. Okay, and then the second question, yes, we arrive at the same answer as well. Let's look at their approaches and see if anything stands out. So the other approach that they show is that you could have literally expanded this sum, you know, and not had the little shortcutty, you know, so, you know, you could have literally gone and calculated this and the 0 and the 1 and the 2 and the 3 and the 4 and the 5 and the 6 and the 7 and the 8 and then added them up in your calculator. That would also be a perfectly valid approach. But of course, we want to equip you so that if they change this 8 and they make it 100, you don't want to be sitting there and calculating 101 terms. You know, you want to be able to pick up what the pattern is and then use your formulae that give you an FT shortcut. Right, thanks for tuning in, and let's catch up again for another question another time. Oops. Bye.